So you have here an extremely strong panel made up of individuals at the very frontier of this technology, which we're here to discuss. And we're going to get into a bit the science driving this new way of making food, the breakthroughs, the challenges, and so on. And hopefully we're going to do this without running up against anyone's trade secrets or anything else that can't be discussed. We're hoping to frame this as a scientific discussion. And you have a great opportunity here to ask questions via the Slido app, which we'll be monitoring here. So we'll start with Mark Post. It's been about 5 years now since you unveiled your history-making hamburger. A lot's happened since then. Technology has been discussed on the front pages of our paper, the Wall Street Journal, which I guess I should introduce myself. I'm Jacob Bunge, and I cover agriculture for the journal. But to start us off, would you tell us, Mark, a little bit the progress that you've made in your research, the sort of scientific things that remain yet to be unraveled as the food moves towards people's dinner plates?
Right. Yeah, it's I guess we launched that in 2013, not so much as a product, although the whole atmosphere seemed to be like a product launch, but it was mostly proving a concept, telling the world, you know, this can be done, the technology is there, and by the way, we need to think about our meat consumption and meat production. That was the goal of that thing, and we realized, that was kind of signified by the price of the hamburger, which was $330,000. And I emphasized that to make sure that everybody understood that this is not a product yet. And of course, our goal was to make it a product, and for that, a lot of things had to happen, actually. So all the non-replicative animal components in that hamburger had to be removed, which is the serum, which is some of the scaffolding. There was no fat in it, so the tasters commented it was kind of dry, which it was, I agreed. And so we had to produce fat tissue. And of course, in the end, it's all about efficiency of using resources to create a certain amount of meat. So for that, you need to scale up, and you really need to sort of decompose all the parts of the process to be able to make it efficient. Because cell culture in itself and tissue culture in itself, as it has been used for the last 130 years, is not really a very efficient process. So you need to work on it to make it efficient. And actually, a lot of our colleagues still think we are absolutely crazy because they think you cannot make this efficient at all. And efficiency translates into cost efficiency at some point, which has additional dimensions, which GFI has worked a lot on, and for which we are pretty grateful to provide that insight. And then in the end, you end up with a hamburger that is hopefully cheap but most importantly, resource efficient. And once you have that, you immediately start to think, and everybody, I guess, in the industry is thinking, you know, if we have a hamburger, that's fine, or a meatball, that's fine, or minced meat in general, that's fine, but then we need to move to whole cuts. And the technology is there. The technology is described in the medical field for tissues for regenerative purposes. But it has not been applied to these type of products yet. And in fact, it's still kind of in its infancy in the medical field as well. So I think we need to start thinking about that probably now and start working on those 3D tissues.
Thanks. So Eric Schulze is here. Memphis Meats has been developing beef, chicken, duck using this technology here in the Bay Area. Can you give us a sort of a snapshot of what you've been developing from a scientific standpoint, where you hope to go, and so on?
Sure. And it's great to be sitting next to Dr. Post here, because we owe him a lot of gratitude for sort of kicking us off in a way that's moved it into pure commercialization at this point. And I think one of the things that highlights how the Memphis Meats approach the R&D perspective is a highly interconnected, interdisciplinary approach to science, because you cannot go to school for this currently yet. And so plucking people out of graduate programs for science and technology is not necessarily something you can do, but also relying on hiring people that are, more along the lines of expert generalists, people that have a specialization, but are incredibly good at being able to take their skills from the disparate, the orthogonal, the adjacent areas of science and technology and engineering they come from, food science included, and applying that to the commercialization of a product or rapid prototyping, rapid iteration. And then in the time that Dr. Post here debuted his products and his prototypes, Memphis Meat didn't yet exist, and then we were the sort of first on the market or the first company that sort of existed to try to bring this to market explicitly. And since then, we've been happy to see that it's just exploded. There's tons of new entrants into this space, and I think that's going to further accelerate the R&D aspect of this as well. And I think that also how we approach the R&D aspect as well to product prototyping, we've released 3 as you mentioned, is this idea that we're not trying to mimic physiology as much as we're trying to orchestrate physiology. And I think that's a really fundamental approach to how you design food in general. And I think that we take at heart, and that's also at the heart of the interdisciplinary approach we take in designing food at Memphis Meats and designing our products and food production. And at the end of the day, this all centers around a healthy culture that you build at your company. And I think also, and credit to Dr. Umar, our CEO and co-founder, to helping build a healthy culture that can support a really robust long-term R&D program.
We have here Neta Lavon. She represents Aleph Farms, and you were established last year, and you're taking a somewhat different approach here, involving three-dimensional tissue formation. I wonder if you could talk a little bit about the scientific approach that you all have mapped out and how you differ a bit.
Okay, thank you very much for inviting me to participate in this pioneering panel, and for GFI for the support that they give us all year round. And actually, Aleph Farms' vision is a little bit different. The gold standard today is to produce a cell mass and then use it for the final product. A meat is actually a tissue, a complex tissue that is comprised of several cell types together in a three-dimensional structure. And at Aleph Farms, we believe that this is the way that we should pursue, and we have an access for the technologies of the Technion Institute of Technology in Israel for Professor Levenberg's technology. She's a world expert in tissue engineering. And by this license and access to our technology, we are able to build a real tissue. We believe that the consumer is actually looking for this kind of meat, and only by this we will be able to actually penetrate the market and have something that will be appealing enough in order to replace the conventional meat that is actually now grown and sold. So this is the approach that we are taking, and in order to pursue it, we have a large team of scientists that are actually coming from different directions, from cell biology, from stem cells biology, from tissue engineering, materials engineering, and all of them together are actually making this vision come true.
So Liz, everyone, I guess, knows you at this point, but can you give a sense of how the Good Food Institute is involved in pushing forward the scientific picture?
Absolutely, yeah. So from the SciTech perspective within GFI, we really see ourselves as triangulating 3 things. One is identifying high impact projects. What are the technological needs, mapping out that needs landscape and putting that into materials, resources, white papers, peer-reviewed papers, et cetera. So projects is one. Equipping people to address those projects, so reaching out into various scientific communities, many different disciplines, as everyone's mentioned up here, to really put these projects on their radar as really fascinating, juicy areas to delve into. That could be academics, talking to folks at conferences. It could be working directly with the startups themselves, helping them source the right talent, providing feedback, and reaching out to industry. So workshopping with folks in, say, the life science industry to help them figure out how they develop enabling technologies. So identifying projects, equipping people, and then the third element that we triangulate is the funding. So you need capital to make this happen. We work on both the private and the public side of that. As Bruce mentioned in our intro, we are starting to get more involved in direct research funding through our competitive grants. But we also work to kind of leverage funding that exists out there in the world, say through agencies like NIH or NSF. They're already doing grant funding on very related fields, but maybe for a different application, say a biomedical application. So working with their program officers to prioritize this as something they should be funding. And then on the private side, working with investors to educate them about this space, make sure expectations are aligned, make this an accessible area for investors to get involved in.
So you mentioned, and so did Eric, the backgrounds here, scientific backgrounds that are feeding into this area of research, this technology. What sort of scientific backgrounds do you encounter, when you're looking at the companies or at academia that are feeding into this? Is this stem cell technology? Is this chemical engineering? Is it other things? Is it all the above?
Yeah, great question. So I think we've heard threads of this. This really is interdisciplinary, and we need a really diverse talent pool. I think there's a lot of strength in people who have cross-disciplinary work. I'm maybe biased. I'm both chemical engineering and molecular biology in my background. But I think a lot of the teams that we're seeing are playing these strengths off of each other in a really interesting way. But in terms of who do we need in this field, biochemistry, cell biology, things like that are somewhat obvious, even developmental biology, but also every flavor of engineering, even non-obvious ones like electrical engineering or mechanical engineering when we're thinking about this from a systems perspective, right? Also, I think data science, computation, there are a lot of fields like that I think haven't necessarily heard the call to action for getting involved in the cleat meat industry, but there is literally room for every scientific discipline.
And Neta, could you give a bit of a snapshot of the sort of scientific backgrounds that make up your research areas?
Yeah, sure. I've been in biomedical engineering and tissue engineering for biomedical applications for a very long time, and this is essentially not very different. It's all the disciplines that come together are already established, kind of in a biomedical frame. So people, students and professionals know this. They know what they are looking for when they apply for jobs like these. What I find is that a lot of young people who are still thinking about their master's degree and even their postdoctoral degree, they are asking, what kind of discipline do I actually need to get into this field, which is very encouraging because it attracts young people and apparently it's an appealing field. Which I understand, of course. But there I usually say that, all the things that Liz said, bioengineering, biomedical engineering, biochemistry, cell biology, mechanical engineering, and we find actually a lot, like for instance, computational scientists, they basically come to us and say, can I contribute to this? So we haven't really searched for them actively, but they really come to us. And then, of course, in the next phase, which is I find myself last year to do the first psychological study in my life ever, and realized that there is actually a whole other dimension in social science that we need to incorporate. And also people from social sciences are really interested in this field and are willing to collaborate. And I think you should not all probably recruit them in your company because there's a lot to be done with alliances with groups that are out there and really interested in this field.
I think that the challenges that we're facing are very big, and we need people that really think out of the box. And we're trying to have a team that is really interdisciplinary and people that have background coming from different fields. I personally did my bachelor degree in chemistry and food biochemistry, and my second degree about transgenic plants, and then my PhD about stem cells and cell biology. So having a background coming from different direction, looking from different angles on the question that we are trying to solve really helps to think out of the box and bringing all kind of innovative technologies that are really crucial in order to solve the challenges that we're having.
I can jump in just for a sec. Also, I come at this from a STEM education policy perspective as well, and I agree. I also want to add that science does not occur in a cultural vacuum, and that 90% of this planet consumes meat in some way, shape, or form every single day. And the representation of that cultural viewpoint should be reflective in the companies trying to do this work. And again, we're trying to do that at Memphis Meats as well. And Megan Pittman, our director of people operations, really has been leading that at Memphis Meats. But having diversity at the center of any hiring schema, regardless of the scientific field, I think is going to be really important as well for the entire field.
So Mark, I wanted to go back to you. As you've brought the burger, there's been other meats that have been done since then. The idea still is out there. The question of how realistic is the prospect of this technology replicating a more complex product, a whole cut of meat, a ribeye? What do you think?
Well, I think it's very realistic, and it's a challenge because there are a couple of technologies that you need to add on top of what you do when you rely basically on self-organization of cells to create very small tissues. If you create larger tissues, you need to impose a larger 3D structure on the cells, and you need different biomaterials that are stiffer and are resisting the forces that are generated by the muscle cells. You need, and for that you need a 3D form fabrication method of that. There are plenty of them around, so it's basically pick and choose from those technologies. Then the second thing that you need is to co-culture cells. So currently we're culturing muscle cells and we're culturing fat cells and tissues, and you use different triggers for those. And if you want to combine it in one tissue, which of course is doable because as we are sitting here, we're all doing that in our bodies. So it's doable with one sort of perfusion system, but you need to figure out the really timing of the different differentiation processes, and that just takes time. And the third, probably most important, is that you need a channel and perfusion system to distribute oxygen and nutrients sort of evenly through that tissue and to remove waste material. And again, that's why you and I have blood vessels. But blood vessels are typically a very, very difficult type of structure or intelligent type of structure to work with a fluid that is extremely difficult, blood. And since we don't use blood here, we can actually create easier channels for that purpose. So I think there are a lot of opportunities, but nobody really has done a significant amount of research on this yet. So I'm excited to see what will happen in the next couple of years when people start to think when they produce 3D tissues, not in tissues that necessarily need to be functionally integrated into the body in terms of its circulation and innervation and reaction to hormones and stuff, but are actually just look good, taste good, and feel good. So that will be an exciting area.
So Neta, this is something that you're driving towards as well. I'd be curious, the same sort of question. Is there, for the master beef tasters of the world, which is a job that does exist, by the way, will there be a time when they might not be able to tell the difference? And Eric, I'd be curious your view too.
So I believe that very similar to what was discussed yesterday about plant-based, protein-based products, it would be very hard to mimic one-to-one what nature has done. And actually, we're not trying to mimic it exactly as it was done. And we can do it differently and even much better or different. And by doing it different, we can do it with new textures and new taste that the consumer will really like and even prefer over conventional meat. So I think that we shouldn't look at it as something that we're comparing, but we should look at it as something that has some benefits in terms of texture and taste, And that's what we're trying to do in Aleph farms in terms of building a three-dimensional tissue based on a scaffold that will give the tissue some properties, very interesting properties. So that's how we see it.
I would agree with Dr. Lavon. I think that the key thing also is that our products are meat already down to the cell. They're from there, and I get to taste them every day, and I like to think that I can't tell the difference. I don't know if that speaks more of my palate than a master meat producer, or if we're not quite there yet. But we eat it every day, and I think that it already is there. So I see no reason why it can't be or compete already with those on market. And then, as we've all sort of suggested, I think also dialing into having a substantially equivalent product to things that are on the market right now, but maybe pushed up towards the upper end of things we desire, or minimizing the things that we're not looking for in product specifications, for example. But it's an exciting time because of all the entrants in the space now, what the possibility is going to be from all of everybody's corporate approach to designing products.
I think here, actually, surprisingly, social sciences come in big time, because whatever, if you make products that are completely new, then of course they will create a market, and there will be a market for that. But the question really is, I guess we are all still very much mission-driven in trying to turn around the tremendous meat consumption and meat production that we have in this world. And if you want to do that, you have to replace those traditional tissues. You can replace them with something new, or you can replace them with something that is identical but just made in a different way. So those are two different philosophies, and I think there is sort of a gradient among the different companies on how they approach that. But in the end, it's probably the social sciences that are going to tell us or give us cues to which of these approaches or hybrids of these approaches are actually desirable.
I'll jump in with one last thing because I like where this is going. And since this is R&D focused, we should. Also, this idea, too, that while we eat muscle tissue and meat is a complex tissue in itself, and it's very hard to break down individual points. And from a reductionist point of view, there are key elements to meat and meat tissue that are going to be the sort of key drivers of what people want and taste. And those are, I think, the things that this industry is still working out. And it's not just building the tissue mass itself, but what are the key drivers of flavor and organoleptics that we care about? And that is where I think many of the R&D, whether directly or indirectly, we're all working towards figuring out as fast as we can.
Yeah. If I may add, we spoke yesterday about the experience, having this experience and joy of eating and how it gets similar to what we were used to eat in the past. So if we can supply this experience and joy, that's what we need to do. That's what we are aiming to do.
Liz, we talked at one point, I think, about the ability for the beef connoisseur to taste the difference between product from an animal that had been raised in a field of clover versus alfalfa. I'd be curious, how much capacity there is with this technology to, in sort of the way that's been discussed, like play around a bit with the taste profile and other aspects of like what Neta just spoke of.
Yeah, I think, again, we've teased that a little bit here. Eric bringing the word organoleptics, which is one of my favorites. What I think is fascinating here is the degree of control we have over a platform like this compared to the amount of randomness and uncontrollability when you're talking about an animal in a field or in a cage, not just from a flavor perspective. The clover versus alfalfa question is interesting because those, we see them as different feedstocks, but when they get digested by the animal, those result in different kind of palettes of biochemical molecules that then are metabolized by the cells. So we can actually figure out what that signature is that produces a certain flavor. And beyond flavor, texture too. Again, the uncertainty of having an animal, if you have a cow in the field that gets kicked in the thigh and then you've got a tough bit of scar tissue in that cut of meat, as compared to this process where you are controlling all of the parameters and you get that robust reproducibility. This is actually the aspect of the process that when I talk to meat scientists, which I do with some regularity, their eyes light up the notion that you could have this degree of control, and no one knows better what defines a high quality meat, the best meat you could ever imagine, than a meat scientist. And you're basically handing them a platform in which you can dial that in over and over and over.
So let's take
I think this is actually an important point, which we tend to overlook, and which we also tend to look at it in various ways. I'm from the Netherlands, and basically in the Netherlands we have very poor meat quality because it's a byproduct of dairy. So it's basically all dairy cows that eventually end up in the meat sector. And so it's highly variable, so you never know what you're buying. The only thing you know that the price is high. So when I started talking about this control and about making tissues from moment to moment exactly the same and exactly reproducible, there are two elements. One is, well, that's boring. Maybe that's not what we want because it's sort of unnatural, and so there's a whole sort of set of values behind that. But the other thing is, if you tell this to people who run supermarkets, they said that's exactly what we need. I think the fact that we have control over how the eventual tissue looks like and feel like and tastes like is going to be an important issue.
And again, I think that we can learn a lot. Dovetailing on this is reaching out to people with the most experience as well. We have been, cultivating domesticated animals for over 10,000 years on this planet. So ranchers and producers have an intimate knowledge of sort of what, from their perspective, drives flavor, and we can use that and complement that with the innovative ways that we as an industry are moving forward in the ways that they could maybe see some of the ways that could improve our products and tissue. So we can get on market with even learning and synergizing with them in the R&D efforts and learning from traditional producers.
Let's take a question submitted here, and we'll not hold it against this person who seems to be going after some insight on your plans for developing media for the cell culture process. So maybe we can ask this in a slightly different way. In the sense of maybe the pluses and minuses of various types of media used in this process, and the challenges of scaling it up, either in terms of production or the manufacturing of the media itself.
Right. Well, sorry. I think this is a crucial point, because this is where eventually the efficiency and the cost effectiveness is coming from, because 80% of the cost of the final product, roughly, is going to be the feedstock that we feed the cells with. So paying a lot of attention to the medium is absolutely critical. And of course, there are a couple of obvious characteristics that the media needs to have. It can no longer contain animal-derived products. So serum is out of the question. I got a lot of questions about this. It's still out there, that story, but it's out of the question that we use serum for this purpose, for various reasons. But the most obvious one is, our intention is to reduce the number of cows from 1.5 billion to 30,000, and then we don't have serum anymore to grow our cells. So that's the most of the obvious circle that will not work. But there are other components that are in there that may or are developed for a different purpose, are developed for a biomedical sort of science community, for a pharmaceutical science community, and nobody looks at the price. Nobody looks at the source of it. Nobody looks at the scalability of the whole thing. So that is something that has to be developed. And basically, the approach that we are taking is remove all the dogmas from this field and start all over again. What are the simplest ways of doing this? I really like the image that Yuki from Shojin Meat at some point put forward. Let's take Gatorade and try and see whether it works for these cells. Unfortunately, it didn't work, but the idea is because it was too acidic, and so he reduced the acidity, and then it kind of worked. But so that's probably sort of the extreme of the whole range. But we need to think in terms of these type of approaches and break down all the dogmas, and they're trust me, there are a lot of dogmas in science. Break down all those dogmas and start all over again. What are really the essential components that we need in that medium, and what is the easiest way to get them? And then you need to start thinking about where you source those materials from. So we recently came to the conclusion that there is basically only one industry that is capable of sourcing this and probably has the incentive to do that, and that's the feed industry. We don't think about that every day, but it's a massive industry. It's, for cows, it's 8 times as big as the animal industry, because that's the conversion rate in a cow. So we need to address that as a feedstock for the serum and try to minimize the amount of hydrolyzation or chemical sort of perfection of those components in the eventual medium that we're going to use for the cells. And that's a completely new field.
I'll just quickly add that I think the difference between our products being price premium and mass market is the cost of the media. I think that's going to be the single largest. I completely agree, and I think most people here would agree as well. So that either means we're working at commodity level pricing, bulk level pricing for this, or asking more of the cells themselves. One of the two things needs to happen in production. I don't know, Neta, if you had anything.
Yeah, one of the things that we're actually doing is optimization of the concentration that are conventionally used in growing cells, and actually reducing the amounts of growth factors that we are required, which actually the most cost-effective manners in this media. We need to produce more stable proteins that will actually, again, will help us to reduce the amount of growth factors. And actually, by building a tissue, we have the advantage of the crosstalk between the different cell types. And by this, we can also use a media that is less rich with nutrients because the cells actually support each other. So this is one important aspect of building a tissue that can help us at the end reduce the price of the growth media and the production as a whole.
Liz, do you have anything to
I think they covered it all. I think, Mark, you hit the nail on the head here. There are so many assumptions about the way in which media has been optimized for the biomedical industry that we simply need to toss. We need to look at the bulk components. What do cells need? What can we ask the cells to do? And I see this as there is a path forward.
There's another interesting question here that I had a form of this phrased in probably a more rambling fashion. But you talked a moment ago about the capacity to play around with the taste, texture a bit with the control of the process. The question is this: will consumers of clean meat still suffer from illnesses like heart disease and cancer that are associated with animal consumption?
Yes, they will.
Set aside
one illusion less, I guess.
From the MD on the panel.
But you should refine that probably a little bit. There was a discussion yesterday about what the health detriments of eating too much meat are. And there are basically two that we can think of and that are widely published. It's cardiovascular disease, which is associated, presumably, and there's evidence for that, to saturated fatty acids in the meat. And the other is the increased risk for colorectal cancer, which has been attributed to a couple of things, but because it's related to red meat, people have focused a lot on the heme iron in the meat. And it was, I think, very rightfully commented yesterday by Celeste that evidence is not very strong. So we need to think about that. But here again, the potential of this technology is that we can basically change those products slightly, even without genetic modification. We can coerce fat cells to make omega-3 fatty acids, so that would lower your cholesterol. And we can actually dial in, we can sort of titrate the amount of myoglobin in the muscle cell, and therefore titrate the amount of heme iron. If that indeed turns out to be sort of the cause of the increased risk for colorectal cancer, which I have actually sincere doubts about. Because if you think, well, I will not go into details, but because it becomes very complex, but the heme iron that colors our meat red is not the only heme iron protein in tissue. It's only half of the heme iron protein in that tissue. So I don't know exactly whether that, and those are kind of indispensable, so we cannot really change them. But the heme iron we can. And if that turns out to be the cause of colorectal cancer, then yes, we can do something about it.
I'll lean in a little bit with
Something that I think gets overlooked, but again, I think it's very important. As a former federal regulator and policymaker, the regulatory implications of this are quite significant. If we're going to make as an industry a health claim about a food product, that gets into sort of a gray area of validating that claim from a health perspective, and regulatory bodies will certainly be interested in how you're validating that and informing consumers of its health benefits. So if we're saying, for example, we're making heart-healthy meat products, that will have to be validated by a federal body, at least in the United States. So while I know we're not here to litigate association studies on health effects, I do want to posit that as something to consider when trying to propose that there might be an added health benefit or value, and it shouldn't stop anyone from pursuing that if they want to do that from an R&D perspective. But definitely check with federal regulatory bodies if you're planning on doing something like that.
Yeah, but what you can do is label it as this has omega-3 fatty acids, because that's just a compositional analysis.
Absolutely.
And then I guess the knowledge about that in the general population is such that they will translate that into a health benefit without having to claim, because I completely agree. Claiming health benefits of a food is horrible. It's really, from a regulatory perspective, it's a nightmare. That's why most of the people in the industry don't do that.
I may add, I believe that the fact that we actually control the whole process, the fact that we actually control the process of production and the source cells actually allows us many health benefits. And one of them is actually controlling the issue of microbial contamination. And microbial contamination mainly comes from the slaughterhouses. And our meat is not exposed to this stage of production. So having the control, working with cell banks, which are actually banks of ampules of cells that are frozen for long storage in liquid nitrogen, having ampules with the same cells that are fully characterized really allows us to do a thorough testing of the initial properties of the cells, and again, going back to the same cell source and using it to produce many batches. So the source material will be very much controlled in terms of microbiology and avoiding pathogens and all kinds of diseases related to it. We also believe that the issues of antigens can be controlled, and this is one of the reasons for all kinds of health issues related with meat. We're not using the sera or the blood that actually flows into the tissue in the conventional growth of meat, and we believe that this is something that we can also reduce and control in the process.
Can I say something else? Because I think we have covered all the potential benefits, and those are important. But there is the idea out there, the public is primarily interested in safety. Is this food safe? And is it not only safe now if I eat it tomorrow, but is it safe if I eat it for the next 10 years? And of course there are, so that's why there's regulation, and we actually should embrace the regulation as a instrument to tell people, oh, we have done everything we could to make sure that this is safe. And if from a compositional point of view, this is exactly the same tissue, there's no reason to assume that it is not safe. Yet, there will always be this question, you produce it in a different way, do you introduce some unforeseen, and they're unforeseen so we don't foresee them, aspects of this meat that will have at some point a health issue. And so and there's no way of, by the way, it's the same with pharmaceutical industry. It's exactly the same. You do extensive tests, but they're still in numbers, a limited amount of tests on, let's say, 10,000 people, and then you roll it out to the entire population, and you find very, very rare side effects. And we are going to face something similar here, I think, and that's why I would suggest to the regulatory authorities to have a sort of post-market surveillance on these products, so that you can actually, if something comes up, you will know and you can trace it back to where it comes from.
I think, and I'll just jump in quickly. I think we'd be remiss on the question of health to not mention the public health implications of animal ag as currently done compared to this system. So I know we've talked about antibiotic resistance and what a looming nightmare that is. Quite frankly, the vast majority of antibiotics, at least in this country, are being fed to farmed animals. You can see very direct correlations by profession for people who work directly with farmed animals in terms of the rates at which they get multi-drug resistant infections, if you're a slaughterhouse worker, if you're a veterinarian working with livestock, et cetera. And then the other issue that I think we should be cognizant of is zoonotic diseases. So again, many of these really potentially pandemic threats often emerge or can be traced back to intensive animal operations. I was at a panel recently about global biological catastrophic risks, and a viral expert was saying there's two populations they keep an eye on to look for what they call viral chatter, anything suspicious that might suggest recombination into something that could transfer into humans. They look at bushmeat hunters and they look at abattoir workers, slaughterhouse workers, as kind of first signs of anything concerning going on there. So I think that's an indication of the system we're coming from, and this, of course, eliminates that entirely.
And I'll jump in, going back to Dr. Post's point, is also, put very simply, if you're producing food, you are a regulated industry in the United States. There is no if and or but about it. It's a regulated industry in this country. So that's the good thing. And I think that, and we've taken this approach, which is building regulation and regulatory strategy into your R&D efforts from moment one. And I think that's not as common as I would like, but we hope that, and again, we encourage this, and I think everyone is considering it, and not that people are not. And luckily in this country too, there's post-market surveillance for food in this country, which is excellent, and I hope that sort of spreads across. But again, just making sure that regulation is a part of your R&D efforts, I think, is going to go a long way against mitigating risks for health of the public and instilling consumer trust for any product that goes to market.
I wanted to get everybody's thoughts quick. We talked a little bit earlier about the other scientific disciplines and areas that are being drawn upon and have been drawn upon to help to develop the technology that you all are pursuing. But if we flip this around, the work that you all are doing in research development and figuring out these processes, what works and what doesn't, are there going to be things in the way of breakthroughs or new processes that this industry produces that could inform or benefit other industries, animal agriculture as it has been done up to this point, and so on?
I'll jump in with kind of a paradigm that I think cuts across many fields, which is a movement towards doing R&D better and faster. So high throughput methods, microfluidics, in silico modeling and computational methods. All of these allow us to run tens of thousands of experiments, actually physical experiments or in silico experiments at once, and gather far more information than we could have just a few years ago. And so when we're looking at the complexity of, for example, optimizing cell culture media, right now there might be 50, 60, 70 components in there, and it becomes this this kind of design of experiments nightmare. But now we actually have systems where you can vary all of those in tandem and do this in a really systematic way. So I think that's incredibly powerful. And we heard that come out in some of the pitches yesterday. Quite a few of the pitches mentioned things like computational modeling or automation, these high throughput approaches. So I think we're seeing that across the board in many fields, and that will apply here just as strongly.
Right. And that, it's a difficult subject, I guess, but it would be really important to, which we see in the biomedical field, is that a lot of data is shared. And of course, that sort of is tricky in a new industry where you have trade secrets and you want to protect your technology. But there are various ways of sharing information and data in public databases that do not really impinge on trade secrets, and where you can still remove a lot of the redundancies in the research that's being done by the various groups.
Maybe, I was going to say, so we just have a few minutes left. If we could cast things forward a bit. In 50 years' time, what do you see the role of this technology being? Will plant-based products, for instance, be enough to satisfy demand for more basic things like ground meat? Will it be whole muscle cuts and those sorts of things where the cell culture technology distinguishes itself? Will traditional livestock production be dominant and this all be sort of looked upon as a Betamax type of moment? Neta, you want to go to this first?
I believe that so in the grocery section of steaks and meat cuts, we will definitely have the advantage when we work with the animal cells. When we speak about processed food, I believe that in the future we will also have the advantage, because actually the cell is a very complex structure that has thousands of molecules that are expressed and are contributing to the organoleptic properties of the final product in terms of texture and taste. So I believe that the plant-based industry really did a great job and a great progress in actually trying to get very close to the taste of a meat cut, or processed meat. But it is difficult, much more difficult to mimic it, and since we have the original cells with all the complex molecules and the interactions between the different molecules, have the advantage over synthesizing it, outside of the cell and finding the right combinations. And I really take the analogy from the pharma world where I'm coming from. So in the beginning, we used to use single molecules for curing all kinds of diseases. And then we moved to actually combinations and cocktails of different molecules for much more complex diseases. But in the last 20 years, it's the cell therapy era, which means that we're using a whole cell in order to cure uncurable diseases like ALS, for example. And that's my experience coming from a company in Israel called Kadimastem that actually does cell therapy for ALS. And we were allowed to do it because the cell is doing several mechanisms that actually help to solve this issue, this pathology. And I believe that the same will happen when we're trying to create the tissue, the meat tissue, for consumer, for food.
I get this question a lot, and people come at it from both directions, and I certainly don't have a crystal ball. Some people say, is clean meat the sort of stopgap measure to get us all to ultimately being plant-based, but we just need clean meat now because people grew up on meat and they won't accept anything other than genuine meat. Other people say, is plant-based the stopgap? And once we have a world where we've got cost-competitive clean meat, everyone will prefer that, or most people will prefer that. I honestly see room for both of these in perpetuity going forward. I think what we're doing here is expanding the number of options available to consumers. I think we may see certain technologies play more strong of a role in certain product categories than in others. So I think your whole tissues comparison versus ground meat or minced meat products is apt. And then finally, I'll just say in terms of the role of traditional livestock going forward, I don't know that we'll get away from that entirely, but I think there's a parallel we often draw looking at just kind of technological progress, where we say, it would be absurd to think of using horses for transportation. None of us arrived by horse to this conference.
Speak for yourself.
I did not. But people do ride horses recreationally, and in other countries where there's not access to modern forms of transportation, that is still used. And so I think Yeah, I think we need to think about this holistically, but the number of benefits that both plant-based and clean meat offer is clear. It's straightforward. So I think for the mainstream, this will be the direction that it goes.
Yeah, I don't have a crystal ball either. And as a scientist, I have particularly problems with trying to predict something that I have no idea whether it's going to happen or not. But you can make a couple of observations and try to extrapolate that from sort of towards the future. One observation that I've been making in the last 30 years is that the ethics around animal use for human purposes is changing linearly. So I've seen sort of the ethical discussion around that gradually from no discussion at all to more and more concern. That's very evident in using lab animals for research, and it hasn't really caught on to animals for consumption yet, but it definitely will go into that same area. So I think that ethical concern is a big driver for going more and more towards a plant-based diet. And if you now look at younger generations, you see that happening. And of course, that's where we should look for the future. Can products like cultured meat, can that actually be an accelerator of that process? I think it can. And I don't know for sure whether it will, but it has that potential that it will be an accelerator of that process. The other observation that I have been making, and that's you can all check those observations because I think you make the same, is that we have an increasing choice in our foods, and we kind of see that as progress, right? That's a bit of a loaded word, but we kind of see that as progress, that we have ever more options in our food and accessibility to food. So it would be kind of strange to assume that we will voluntarily reduce that number of options in the future for whatever reason. And if we can find technological solutions to keep having those options and move forward, then we are likely as a species to do that. So those are the two observations that I made that allow you a little bit of a window on the future.
Really briefly, I know we're at time. Science and technology are premised on the fact that if we've seen farther, it's because we've stood on the shoulders of giants. We borrow from each other. We march forward and question because that's the only way we can progress. And arguably, food innovation has defined us as a species and our inexhaustible success as a population on this planet, and that will not end anytime soon. We will have 10 billion mouths to feed in 50 years, and that will have to happen daily. It will take every single person in this room and every option we have on the table and relying upon the shoulders of the giants that are in this room right now. So I think that's where we're going.
Thanks to the panelists here.
Thank you.